Let's begin by first announcing the webinar disclaimer, as is what I have to do every webinar. This WebEx service includes a feature that allows audio and any documents and other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, then please do not join or participate in the session. The WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. All right, so this is coming in kind of handy due to our snow day today. I do want to get into Chapter 2, since we will just be spending 1 week in Chapter 2, and it is kind of an important chapter. All right, the motivations. In the preceding chapter, you learned how to create, compile, and run Java programs. Starting from this chapter, you'll be learning how to solve practical problems programmatically. Through these problems, you will learn Java primitive data types and related subjects such as variables, constants, data types, operators, expressions, and input and output. Chapter 2 takes on a lot. Okay, the first thing we're going to do is start back from where we started in Chapter 1, and that was computing the area of a circle. This program computes the area of a circle, but it will now use variables as opposed to just calculating an expression in a system.out.println statement. Let's look at the program compute area. I've got a preloaded NetBeans already. See if I can make this a little bit bigger. Okay, we got a package statement for compute area that corresponds to this compute area package. Notice that it's all in lowercase. Packages by convention are in lowercase. The next line says this is the start of a class. The class is called compute area. It's got the proper conventions. It's got the proper casing. We have an uppercase for C and an uppercase for A. Each break in Word should be capitalized, should be in uppercase. So we have compute area in the proper casing. Here's our starting and ending curly braces. Next statement, next line is going to be the declaration of the main method, which starts at the first highlighted curly brace and ends at the second one. And note how they are lined up directly under the P in public for each corresponding one. All right, the first thing we're going to do is we're going to declare some variables. We want to compute the area of a circle. So the variables should be the radius and the area. We are declaring a variable called radius, and it is going to be of the type double. Who just joined? Hi, who just joined? Is this Oscar? I guess, Oscar, we can't hear you. You may need to activate your audio by either calling in via your cell phone, or you can call in via your computer or take yourself off of mute. I see you've just gone to mute, so I'm going to continue. All right, so we're declaring two variables. The first variable is radius. It is going to be of the type, the data type, double. This indicates that it's going to be a numeric data type, a specific numeric data type. And here is a line comment that indicates that this is declaring the radius. The next is declaring the area, and that's going to be a variable. We created this name just called area, and it too is going to be of the type double. Now we're going to assign a value to the radius variable. Assignment statements have an equal sign, and assignment statements go right to left. We will take the value 20, and we're going to assign that over into the radius variable. Now the contents in storage that is named radius contains the value 20. Now we're going to compute. We don't need anything else. We don't need to assign any other variables. We need to compute the area and then assign that into the area in storage called area. All right, so we have radius equal to 20, and we're going to now do this calculation to the right of the assignment operator. This is not an equal sign. This is now referred to as an assignment operator. This variable called radius, which has the value 20 in it, is going to be multiplying this area in storage called radius, which also has a 20 in it. So it's going to be 20 times 20, which is the radius squared, times pi, 3.14159. And that whole evaluation, radius times 3.14159, is going to be calculated and then assigned over into the area in storage called area. Remembering our orders of operation, when you have multiplication, we have two multiplications here. We have the radius times the radius, and we also have the radius times 3.14. So there are two multiplications here. Whenever you have the same level of precedence and multiplication and division have the same level, then the computer will calculate left to right. So it will do this operation first, this multiplication, and multiply the radius times the radius and get 400. And then we have 400 times 3.14159, and that will calculate the overall area. Assign it into the variable called area, and now we do our system.out.println, and we have a literal string right here, and it ends at this blank, and we're going to concatenate this literal string together with this radius, which is 20, and we're going to concatenate another string that has a blank is blank, and we're going to concatenate another variable called area. Let's run this, and we see that the area, make this a little bigger. Well, it's not cooperating. The area for the circle of radius 20 is equal to 1,256.636. Okay, so it did the calculation correctly, and let's just reflect back upon these data types here. These are what are known as primitive data types. And the first one we're introducing you to is the double data type. And the double data type essentially says that the data that's going to be in these two areas in storage is going to have a fraction. It's going to be a large area in storage, and it will contain fractions. And sure enough, as you can see by the result, although this is an integer, it could take 20.1 or 20.2, but we are giving it an integer. It will get evaluated as a decimal, 20.0. And also, the area variable is also of type double, so that means it can handle fractions. And when we did this calculation, and it came out to be 1256.636, that got assigned into the variable called area, which got displayed down here. And it yielded this calculation with the fraction. That's a rather simple program just to compute the area of a circle, and it does demonstrate the introduction of variables. And in this particular case, we are just using one data type. That data type is double. Let's step through a trace of this program. When you declare the radius of type double, well, in storage, memory is allocated for this area in storage. It's annotated as a box over here. There's currently nothing in this particular area in storage. In fact, it's garbage. Okay, it could be a bunch of zeros, a series of zeros and ones, or bits and bits, and there is currently no meaningful value in there. It is garbage. When you declare the next area that happens to be called area of type double, well, it does the same thing. Allocated memory for the area variable, and again, this has garbage inside it as well. Skips over the line comment and goes to radius equals 20, which really means 20 is going to be assigned into the variable called radius. And now we see inside the area in storage, there is a value of 20. Next step, we are going to calculate, we're going to compute the area by multiplying radius times 3.14159. And when that calculation gets completed, it gets assigned into area, and it gets placed in RAM in this area in storage that's been allocated for the variable area. Lastly, we're going to do our system.out.println statement, where we have a string, the area of the circle of radius, blank, concatenated with the radius value, which is 20. Concatenated with blank is blank, concatenated with whatever this evaluation turns out to be. And down here you'll see you get the result, the area for the circle of radius 20.0. Notice it's 20.0 because the radius variable is declared as a double. When the console puts this out, it won't put 20, it'll put 20.0 to let everyone know that this is precise. This isn't integer division that's occurring right now. This is actually precise division, which will include the decimal piece. All right, now next topic is to read input from the console. As people are joining, let's see, we got a few people joining in here, so just please, Joseph, I see you're on. If you could just put your audio on mute, there won't be any distracting background noise. If you have a question, just take yourself off of mute and speak right up. All right, the next slide is to introduce how we can get input from the console. So far, up until now, we've just been putting output to the file. I'm sorry, putting output to the console. Now we're going to go ahead and get input from the console. And the way to do that is you need to create what's known as a scanner object. And the statement that creates a scanner object is this one right here. And you have to make sure that you stick to the proper casing as well. Java is very case sensitive, so you need to identify scanner, which is a class, and we're going to call the object that's going to be created from the scanner class, we're going to call it input. And this equal sign will go ahead and create the object as a new object, and we're going to pass this, whatever we put into the console. So that would be your first statement in your program in order to be able to gain any kind of console input. Number two, use the method nextDouble to obtain a double value. If you can think of the example where we're asking for the radius, well, we entered 20 into the program, but you might want to have the capability of your program to enter 20.1 or 20.2. So we're going to ask for a double, or have the capability to accept a double. That would be to utilize this method known as the nextDouble method from the scanner class in order to get input of the type double. And here's an example. We have system.out.print, enter a double value. Okay, so there's no evaluations going on this. All that we're doing is we're we are sending a literal string to the console. The end user will read that and he'll say, enter a double value. Okay, that I'll put in 20.1 because that is a double value. It's got a fraction. It's got a decimal. The next statement, scanner input, that's where you create. That's this statement up here. You're going to create the object, and it's going to use whatever comes in from the system console. And we will then take the next input dot next double and assign it into a variable called D for double, and it's going to be of the type double. And now you've gotten, if I entered 20.1, now the value 20.1 is in the variable called D in storage, in RAM, and it will be of the type double. Let's take a look at a sample program called Compute Area with Console Input. All right, we got a package statement that corresponds with this package folder over here. And we've got an import statement. I introduced import statements to you before for the input dialog box, or the output dialog box, show output dialog box. We now have to go ahead and get another method that we're going to use. It'll be of inside the scanner class in this package, the java.util package. So this, whenever you want console input, include the import statement, import java.util.scanner. Next is to go ahead and declare the class. We're going to call it Compute Area with Console Input. Notice the casing all the way across. And we're going to have our main method. And we have a line comment. If you could, whoever just joined, if you could just go on mute, it would be great. Thank you. We're going to create a scanner object. Here's our line comment, and this is where we enter this statement, scanner input equals new scanner system.in. Now we ask the question, enter a number for radius, or we request a number, and we want a number that is going to be precise. It's going to be therefore a double, and it will handle any radius, any very large radius, with precision using decimals. The next double method inside the scanner class will go ahead and capture that console input and assign it into this variable called radius that will be of the type double. Then it takes radius, multiplies it times itself, and then multiplies it times this literal value, 3.14159, calculates the whole thing, and assigns it into the area variable of the type double, and then we print it out. The area of the circle of radius, whatever I put in, is, and whatever it calculates out to be. Let's do something nice and simple, and I don't know why that's not staying. Come on. Let's put in 20, the area for the circle of radius. I'm trying to make this larger, and it doesn't seem to want to stay. It's very annoying. All right, so the area of the circle of radius 20.0, it converted it over to a double, which will now have decimal precision. The area of the circle of radius 20.0 is 1256.636. So it calculated it correctly. I'll do something even simpler, like enter a number for a radius, and I'll put in 10, hit the enter key, and it says the area for the circle of radius 10.0 is 314.159. It's a good idea to test your programs using very simple data that you can quickly see whether or not you're doing your calculations correctly. I know pi is equal to 3.14159, so if I put in a radius of 10, it's going to be 10 times 10 or 100. So I'll move the decimal point over 2, and I'll get 314.159. So I know my calculations are being done accurately. So this is an example of using console input. This next example is called compute average. Let's see what this does. Okay, we've got compute average package, and we are importing the scanner class from the java.util package, and we are declaring a class called compute average, and we've got a main method, and we've got a line comment that will go ahead and there's my, oh, here we go. We have a line comment right here that says create the scanner object. We're going to use the same scanner method, and we're going to assign it into the object variable name called input, and then I can use the next double method on this object from the scanner class to go ahead and get 3 doubles, which will be assigned into number 1, number 2, and number 3, respectively, all of the type double. The next thing that happens is we're going to declare and assign a variable called average, the calculation of those 3 numbers divided by 3, which obviously will work out to be the average. These numbers are all of the type double, so this is not integer division. This has precision in the numerator, so it will yield a precise or a double result, and then get assigned into the variable called average. And the last thing that gets done is to output the result. Running this, I'll enter 3 numbers, and I'll put in 2, 4, and 5. And notice I put them in separated by blanks. And what happens is I'll hit the Enter key now, and you'll see the average of 2.0, 4.0, 5.0 is 3.6s. I put in 2, 4, and 5, and these 3 statements took each of those input values. 2 gets assigned into number 1, 4 gets assigned into number 2, and 5 got assigned into number 3. Then it goes right to left, so it calculates the addition, parentheses is first, so it will calculate the addition of 2, 4, and 5. And 2, 4, and 5 comes up to 11. And then at 11.0, because these are all double types, divided by 3, and we're going to get a result of 3 2/3, essentially, but it's 3.66 repeating. That 3.6s will then get assigned into the variable called average, and then it gets put out to the console. Okay, let's talk a little bit about identifiers. We created some identifiers. The identifiers are average, they are area, radius. These are all identifiers. An identifier is a sequence of characters that consists of letters, digits, underscores, and dollar signs. Now, we only used area and radius and average, so we only used lowercase letters. But you can use these other characters. They are available to you. Here are some of the rules, though. An identifier must start with a letter, an underscore, or a $sign. It cannot start with a digit, such as 4 or 2. That is not going to be permitted. The compiler will not like that. Next, an identifier cannot be a reserved word. And you can see the appendix of Java keywords for a list of reserved words. They are things like class and public. Those are all reserved words. So you can't call a variable class. You can't call a variable public. You got to pick something different. An identifier cannot be true or false or null. Those words are used elsewhere, and they too are off limits. And lastly, an identifier can be of any length. It's a good idea to not have them be too long because you're just going to have to keep typing that in. Personally, I prefer having your identifiers as brief as possible, yet as accurate and concise as possible. Okay, so variables. Compute the first area, and what are we doing here? We're assigning 1.0 into radius, and we're going to multiply now radius times radius. 1 times 1 is 1 times 3.14159, and I'm going to get 3.14159 getting assigned into the variable called area. It doesn't show what type the area is. We're going to assume above this line somewhere, it's declared area as the type double. And now we're going to print out system.out.println line. The area is, notice this left-leaning brace, or the left-leaning double quote. That could be a problem. This is a PowerPoint presentation, so it's going to do that. And this one looks to be a straight up and down one, so this will not be a problem to the NetBeans compiler. The area is going to be whatever, 3.14 for the radius of 1. The 1 is concatenated. Compute the second area. So this is another segment of code in your program where you assign radius equal to 2.0. This is why they call it a variable, because in this case, it was 1.0. We were using the same area and storage now in our program to assign a different value. It will vary. It's a variable. In this case, radius is going to be 2. It will contain the value 2 in that area and storage. Does the same calculation, and we're going to get a different area. Okay, declaring variables. So far, we've been talking about doubles. The next primitive data type that I'd like to introduce to you is the int data type. And the int data type indicates that anything in this area in storage is going to be an integer. In other words, fractions are not allowed. We're calling this particular integer variable, we're going to call it x. So x is an area in storage. It's going to be of the type int. And here's the line comment that says declare x to be an integer variable. Next is radius of type double. And you can also have another primitive data type called char, which can receive a single character. And in this particular case, this single character, the name in the area in storage is named A. So this area in storage could take any single character. It could take a Q, it could take a K, it could take a parentheses. Any character on the keyboard can be assigned and stored into that area in storage called A. It's of the type char. Assignment statements. Well, we kind of introduced that before. This doesn't say x equals 1. This says the value 1 is going to be assigned into the variable called x. You need to make sure that you declare your variables before you do any assignments. You can do them on the same line, but you do have to declare them initially before you can assign things into them. So that assigns 1 into x. This one will assign 1.0 into radius. X is an int type, and radius is a double type, so that's all fine. And we are assigning the uppercase a into the char variable called lowercase a. Declaring and initializing into one step is what I was alluding to before. You can declare and initialize or assign into X all in one statement by doing this. Int X equals 1. That declares X to be of the type int, and we're going to assign 1 into that variable area and storage of type int. Likewise, this is declaring the variable D of type double, and we're going to assign 1.4 into that variable. Named constants. You can go ahead and you can declare a constant in your program, and a constant would be any kind of value that is not going to change for the duration of your program. For as long as your program runs, this particular value or this particular area in storage will not change. A perfect example would be the value pi. Here is the structure. You need to first start off with lowercase final, and then whatever the data type is for this constant, and then you put the constant name in all capital letters. And then you're going to do the assignment operator and whatever that value happens to be. For example, if we wanted to declare a constant called pi, you would write your statement as such. Final, double because it has a fraction, uppercase pi, and we're going to assign 3.14159 for the approximation of pi. Another example might be final int size equals 3. Keeping in mind that this is not a variable, this is a constant. So for the duration, for the life of your program, the area in storage referred to as size will have to not change and always be 3. Naming conventions. Make sure that you choose meaningful and descriptive names. Names like X and Y and Z, they're not very descriptive. And as your programs get more and more complex and people add more code to them, you'll find that you need to have more meaningful variable names. So make sure you use meaningful variable names. You can abbreviate. Most programmers do abbreviate because they're not great typists, and I'm certainly not one. That's a great typist, so I like to abbreviate my variables. I'll type in AVG for average or CTR for counter. Those are kind of conventional abbreviations for those variable names. So make sure you choose meaningful and descriptive names. Next, variables and method names. Use lowercase. That's for both variables and methods. Notice that main is all lowercase. If you create a method, later on you'll be doing that. You'll be creating your own methods. You need to go ahead and use all lowercase characters for their names. If the name consists of several words, concatenate all in one, using lowercase for the first word, and capitalize the first letter of each subsequent word in the name. For example, the variables radius and area are fine, but they're not multiple words. They're all lowercase. And the next example, we have compute area. That would be a method. Usually methods might have an action, such as to compute the area. And if you use two words, the two words are concatenated, which means they're butted up next to one another. The first word is in all lowercase, and any other word after that is going to be the first letter in any ensuing words will be in uppercase. So if this was to say compute final area, it would be lowercase compute, uppercase F, lowercase INAL, and then uppercase A, then lowercase REA. That's the convention that you need to stick to. That's for variables and also for method names. Class names. This is review, but you have to make sure that you capitalize the first letter in each word in a class name. The example they use here is compute area. I know this is a class because it has the uppercase C. If it had a lowercase c, I now know it is a method to compute area. But this is a class, so it's going to be uppercase C and uppercase A. Constants, well, you need to capitalize all the letters in constants. And if you have two words, you need to separate them using underscores. The example they use here is pi, which is one word, so that doesn't demonstrate it. But if you have something that says max value, you would declare a constant this way: uppercase max underscore uppercase value. Okay, we've got to describe these primitive data types in a little more in depth. And in order to do that, you have to understand what a byte is. A byte is 8 bits in storage, and a bit can either be a 0 or a 1. It can be on or off, it can be true or false, 0 or 1, clockwise or counterclockwise. It really doesn't matter how you want to think of it. We programmers, we think of it as 0 and 1, but it's binary. It can have only 2 states. And we'll just refer to those states as 0, meaning off, and 1 being on. And each byte has 8 of those. We can go ahead and declare a variable of the type byte right here, and that will go ahead and declare an area in storage that's going to be 1 byte in length, or 8 bits, and these are numeric data types, so it can handle an integer anywhere between -2 to the 7th all the way to 2 to the 7th minus 1. In parentheses, it gives examples. So in a byte data type, you can store any numeric integer between -128 and +127. If it's larger than that, such as -129 or +128, you now need to go to the next larger data type, which would be short. And short is actually 2 bytes, or 16 bits. It's a 16-bit, and it's signed. The first bit indicates whether it is positive or negative, and the remaining bits actually have the magnitude of the number. So this short data type can handle any integer between -32,000 all the way up to +32,767. Those aren't used too frequently. What are used more often than not are integers, or int, and doubles. Integers, and int data type, can handle any integer from -2 to the 31st all the way up to +2 to the 31st minus 1, or the actual values are in parentheses. An int is a 4-byte area in storage, or a 32-bit signed area in storage. The first bit is a signed bit, and the next 31 bits is going to be the actual magnitude of that number. After int comes long. We're just working now with integers. So this is now a long numeric data type, which can handle extremely large integers. -2 to the 63rd all the way up to 2 to the 63rd minus 1, or these values here. So that's very, very large integers. It's actually a 64-bit or 8-byte area in storage. Next is a float. Now we're talking about decimals. And decimal numbers can be stored in 2 different data types. The first one is called a float, and a float can have this range in it, and it's referenced in scientific notation. So this is -3, and this e is 10 to the 38th, all the way up to, this is now in very large numbers here, but it is a 32-bit float number. In other words, it's a 4-byte area in storage that can handle fractions, decimal places. If you need a larger area in storage or a lot more precision, then you would then go to the double data type, which we've been working with all along. And that negative range is from here all the way up to the positive range here. And it is a 64-bit or 8-byte area in storage. So that's pretty much the different data types for numeric data. Again, we will be pretty much using ints for integers, because this range here seems to cover everything that we would need, and doubles for any kind of decimal numbers, because this range certainly covers that area in storage. These two here are known as floating point numbers because there's a point, there's a decimal point, and not to be confused with a floating point, which is a 4-byte floating point number, and a double floating point number, which is an 8-byte, much more precise area in storage data type. Okay, reading numbers from the keyboard. We showed you before how you can bring in a next double, and I could enter 20.1. Well, if I only want integers to be entered, then you might want to go ahead and refer to things using int values. Here we're going ahead and declaring the input object of the type scanner, just as in the example before. And now I know I'm getting an integer from the console, so I'm not going to use input.nextDouble, I'm going to use input.nextInt, open and close parentheses, and it will get from the console the next integer and assign it into the value, the variable called value. It will be of the type int. And here are some other methods that you can use to retrieve from the console all the different data types. If you needed to retrieve a number less than 127, from 0 to 127, you could use byte, and you could use the next byte method to retrieve that. Next short would be for 2 bytes integers. Int would be 4-byte integers. Long is 8-byte integers. Next float for 4-byte decimals, and next double for 8-byte doubles. These are all methods that are available to you. Let's look at some numeric operators. The first one is the plus sign. The plus sign for numeric operators means an addition, keeping in mind that it also can be interpreted as a concatenation sign. And a concatenation sign is when you want to butt two things up next to one another. In this particular case, I want to add 2 values, 34 plus 1. The compiler will go ahead and say, here are 2 values, 34 and 1, with a plus sign in between. Therefore, a value probably wants to be added to another value. And that would go ahead and yield a result of 35, not 341, which would be the concatenation sign. Next is a subtraction sign. That is rather obvious, so you can use these operators, 34.0 minus 0.1, and you're going to get 33.9, assuming that these, if they're variables, they are of the type double. Multiplication is the asterisk sign, / for integer division, and you can go ahead and make it precise now if you put in the division operator a 0.0 or a 0.0 in either the numerator or denominator or both, and you'll get precise. It will be of the type double floating point if you put in the decimal point in there. The next one is an interesting one. It's called a modulus function or a remainder function. And as with integer division, where if I did 4 divided by 3 in integer division, the result is going to be 1. It takes the quotient and throws away the remainder. Let's go with a better example. Let's say 7 divided by 3. The result in integer division would be 2, not 2.3. The fractional piece gets thrown away in integer division, and the quotient is the only thing that gets returned. If you want to get the fraction piece, you can use this percent sign or this modulus operator, and that will return the remainder and throw away the quotient. The example given here is 20 modulus 3. So that is going, the real division is going to be, what is that, 8? It's going to be 6 and 2/3, right? Well, it throws the 6 away and just returns the 2, just returns the remaining piece. So it's 6 with a remainder of 2. It throws the 6 away, and it will return the 2. This does come in handy. We'll go through some examples later on, but this does come in very handy when we're doing our calculations. Here are some examples of integer division. 5 divided by 2 yields an integer 2 because we're dealing with integer division. 5.0 divided by 2 will yield a 2.5 because now we've asked it to be more precise, and it will go ahead and convert these values into doubles, do the calculation, and return back 2.5. 5 modulus 2 will yield a 1, the remainder of whatever the division is. Here's an example. Remainder is very useful in programming. For example, an even number modulus 2 is always 0. And an odd number modulus 2 is always 1. So you can use this property to determine whether a number is even or odd. Suppose today is Saturday and you and your friends are going to meet in 10 days. What day is 10 days from now? You can find that day is Tuesday using the following expression. We have, today is Saturday. Saturday is the 6th day of the week. So if we're going to add 10 days, we can reference Saturday as day 6 plus 10. That's going to be 16, and there are 7 days in a week, so we're going to do with a modulus 7, and that will basically break it up into weeks, and we're going to have a remainder of 2. And 2 would be the 2nd day in the week, so that's our remainder. So after 10 days, the 2nd day in the week is Tuesday. Monday is the 1st, Tuesday is the 2nd, and Saturday is the 6th, and Sunday is the 7th. So that is one way in which you could go ahead and write a program or a small little statement here to determine what particular day it will be 150 days from today. You can go ahead and do it that way using the modulus function. Okay, displaying time. Write a program that obtains minutes and remaining seconds from seconds. We'll look at display time. We've got our package statement. We've got our import to get console input. And we will now write a class called display time. We only have a main method in here. And the first thing we do is we create the object called input from the scanner class. And now we can go ahead and ask the end user to enter an integer for seconds. We don't want fractional seconds. We want integer seconds. We will then use the nextInt method from the scanner class, and assign whatever I put in into the variable called seconds, and it will be of the type int. Next thing I do is I do integer division, right? Because seconds is coming in as an integer. It's being stored in an area in storage that is of the type int, and we're going to go ahead and divide by an integer. Therefore, we're going to get an integer. We're going to get the quotient in return, and the fractional part will get removed. It will be ignored. Next, we declare a variable called remaining seconds. And the remaining seconds is going to use the modulus operator. And we're going to take seconds, whatever I put in, modulus 60, and it will return the remaining seconds that are part of the remainder. Then we print out, system.out.println, whatever number of seconds I put in. Let's say it was 122. Let's run this so we can do this. We'll run this, and it's going to ask me, if I can make that bigger, it still won't stay. All right, an integer for seconds, I will put 122. We know that's going to be 2 minutes and 2 seconds. Enter that, and it says 122 seconds is 2 minutes and 2 seconds. So it calculates correctly. And the way it does it is by this statement right here. System.out.println, seconds, which happens to be 122, that's what I put in, and we stored it into the area in storage called seconds. 122 concatenated with the literal string, seconds, is concatenated with minutes. Well, that's what I stored using the integer division, sorry. So that's 2 concatenated with this literal string here, minutes and blank, and now we're going to concatenate finally the remaining seconds. And the remaining seconds is in this variable here of the type int, and it's going to be whatever the calculation of seconds modulus 60. That would be 122 modulus 60. That would be 2 and 2 seconds. It throws the 2 minutes away and keeps the 2 seconds and stores that in remaining seconds. And then you just follow up with the remaining literal, and that's where we get this output here. So there's a pretty good example of using the modulus function to solve a particular problem. Okay, note, calculations involving floating point numbers are approximated because these numbers are not stored with complete accuracy. For example, we're using doubles now. And if you look at the system.out.println and we take 1.0 minus 0.1 minus 0.1 minus 0.1 minus 0.1 minus 0.1. We have 5 minus 0.1s, right? So 1.0 should yield a 0.5 when you do this calculation. You're taking 1/10, 5/10 away from 1, and it actually displays 0.5 and a whole bunch of zeros and a 1 at the very end. It does not display 0.5 exactly. And that is because floating point numbers are approximations. So you could be off by 1 bazillionth, if whatever that decimal happens to be. Another example, system.out.println, 1.0 minus 0.9 should yield 0.1. But if you run it in your program, it will display 0.099999998. Very close to 0.1, but not exact. Integers are stored precisely, though. So floating point numbers are approximations, and integers are stored precisely. Calculations with integers yield a precise integer result. Here's another example of using some methods at our disposal. Inside one of the system packages, there is a math class which has many methods inside it that you can use. And inside the method is a calculation that saves us from having to do what oftentimes are normal calculations. For instance, the first example is system.out.println, and I am calling the POW method in the math class, and I'm taking 2 and raising it to a power of 3. And running this program, it will display 8.0. 2 to the third is 8.0. The POW method will use doubles, so you can actually raise 2.1, 3, and that will raise 2.1 to the third power. So it needs to use, it'll calculate things in doubles. We know that this is a method because it has parentheses and parameters are separated by commas. So this POW method is getting 2 parameters. The first parameter is 2, then we have a comma, and then we have a second parameter, which is 3. Once those parameters are evaluated to 2 and 3, they then become arguments to the POW method inside the math class, and it will calculate 8.0. Another example is math.pow for raised to the 0.5, which will go ahead and take the square root of 4, and you will then get 2.0. Next is math.pow 2.5 raised to the second power, and you're going to get 6.25, 2.5 squared. This next one uses negative numbers, which is this is the exponent, this is the base, this is the exponent. So now what we have is we have 1 over 2.5 squared, and we're going to get this fraction, 0.16. And then last but not least, there is an absolute method called ABS in the math class, where if I was to subtract 4.5 minus 5, well, that should be minus 5, but the absolute value method, the ABS method, will go ahead and return back the positive result, which is the absolute value. So 4.5 minus 5 with the absolute value will return a positive 0.5. Number literals. A literal is a constant value that appears directly in the program. For example, 34, 1 million, 5.0 are literals in the following statements. We will use the term literal to say we're going to assign the literal 34 into the int variable I. We're going to assign the literal value 1 million into the long variable called x, and we're going to assign the literal value of 5.0 into the variable d of the type double. Integer literals can be assigned to an integer variable as long as it can fit into the variable. A compilation error would occur if a literal were too large for the variable to hold. For example, in the statement byte b equals 1,000 would cause a compilation error because 1,000 cannot be stored in a variable of the type byte. The largest is 127 or negative 128. Anything beyond that range, on the outside of that range, is going to be an overflow. It will not work, and you're going to get a compile error. An integer literal is assumed to be of the int type, whose value is between this and that. To denote an integer literal of the long type, you can append it with the letter L, or this is a lowercase l. I don't recommend you use the lowercase l because that gets oftentimes confused with the number 1. Floating point literals are written with a decimal point. By default, the floating point literal is treated as a double type value. For example, 5.0 is considered a double value. Way back when we were calculating pi in our first assignments, and we had to put 1.0s into our numerators, it turned into doubles by doing that. Not a float. Remember, doubles are 8 bytes and floats are 4 bytes. You can make a number a float by appending the letter lowercase f or uppercase f. and make a number a double by appending a lowercase d or uppercase d. For example, you can use 100.2f to denote or 100.2 uppercase f to denote a float data type, and likewise adding the d's will denote a double number. A double versus float. Again, they are both of the type. They're both floating point numbers. Double is twice as large as float, and if you want to take a closer look at them, the double type value are more accurate than the float type. And then, for example, we use this and we say 1.0 divided by 3.0 is, that's all a string, that's a character string. And we're going to concatenate 1.0 divided by 3.0 is going to display this large amount. This is 16 digits because it's going to be of the type double. However, if we went ahead and specified that it be of the type float by using this approach and putting an F at the end of each of these, you're going to see that it's only going to carry 7 digits. And it will kind of round on that 7th digit. But that is going to be of the float data type. Up here is the double data type. Scientific notation, floating point literals can also be specified in scientific notation. For example, 1.23456 E plus 2 is the same as writing 1.23456 E2, which is equivalent to 123.456, and 1.23456 e to the minus 2 is equivalent to moving the 2th decimal point over 2 to the left. E, or lowercase e, represents an exponent and can be either in lowercase or uppercase. So that was scientific notation. It would be the exponent of your base 10. Arithmetic expressions. If you're giving a math problem that looks like this from your math class, well, you need to go ahead and convert that over into Java code. And we now know that you'd have to go ahead and take this and divide it by 5 and then subtract this big long fraction, which is all of this calculation. Remember that parentheses are done first. Next are multiplication and division, and then last but not least are addition and subtraction. So you have your orders of operation, your PEMDAS, parentheses, exponentiation, multiplication, division, addition, subtraction, and then last is the last fraction here, and you would have to calculate that in the right order. To translate that over into Java code, you need to go ahead and express it in this fashion. And I'll let you look at that a little closer, but this is how you would go ahead and express this mathematical expression up top. Though Java has its own way to evaluate an expression behind the scene, the result of Java expression and its corresponding arithmetic expressions are the same. Therefore, you can safely apply the arithmetic rule for evaluating a Java expression. So we know that parentheses are done first, then exponentiation, multiplication, division, addition, and subtraction. In this long expression, we've got an addition, a multiplication, an addition, a multiplication, parentheses, and a subtraction. Well, the first thing the Java compiler will do is do the parentheses. It then will evaluate this to be 7, and now we have a 7 down here. We've got an addition, a multiplication, an addition, a multiplication, and a subtraction. It does multiplication next. There are no more parentheses. It does multiplication and division. It will scan left to right. Oh, I hit a multiplication. I got another multiplication over here, but I'm going to go left to right. So I'll do this 4 times 4, and that will yield a 16. So now I have an addition, a multiplication, and a subtraction. The compiler will do the multiplication. 5 times 7 is 35. Now the next iteration, I have an addition, and a subtraction. The compiler says addition and subtraction, they're of the same level of precedence. It will go left to right. It evaluates 3 plus 16 and comes up with 19. Now I've got an addition and subtraction, same level. It will do addition. 19 plus 35 is 54, and then it only has one more operation, and it will go ahead and subtract 1 from 54, getting a result of 53. That's how the orders of operations work. Hopefully that helps you out in creating your expressions, your arithmetic expressions. Okay, last slide. This is going to be reminiscent of your last assignment, which is to write a program that converts a Fahrenheit degree expression over to a Celsius expression using this formula. Celsius is equal to 5/9 times the quantity Fahrenheit minus 32. We have parentheses, we do them first. We have a parentheses here and parentheses here, so we go ahead and do left to right. We'll do this parentheses first. In Java, you need to write 5.0, otherwise you're going to get 5 divided by 9, which is 0 in integer division. We want 5.0, so that will be done first. Then this will be done second, and then the last thing that will be done is the multiplication of the remaining two results. Let's look at the program, Fahrenheit to Celsius. Okay, we got our package statement. We have our import statement for the scanner. We're going to go ahead and create the object called input, and we're going to then use input.nextDouble to store some degrees in Fahrenheit that we're going to ask be entered into the console. The next thing that happens is it takes the value Fahrenheit, which is of type double, and replaces that in here with this expression, and it will calculate that and calculate this, and then the next thing, and store it into this variable called Celsius. It will be of the type double, and now we just put the output, Fahrenheit, and whatever I put in is whatever the Celsius calculation is in Celsius. Running this, I can go ahead and enter a degree in Fahrenheit. I don't know, Fahrenheit, it was pretty cold today. Let's say 27 degrees today. Well, 27 degrees in Fahrenheit is minus 2.7 in Celsius. Running it again. If it's a real hot day of 95 degrees, well, Fahrenheit 95.0 is 35 degrees in Celsius. Okay, so that is orders of operation using variables and the levels of precedent. I do want to stop right there. This is a good breaking point right here. And just go over your in-class assignment, which is just an exercise in what we've just been discussing. Your in-class assignment or in-class 02, for those of you that are in the online class, this would be your pre-lab 2. It's essentially the same exercise. What I'd like you to do is write a Java program that prompts the user to enter a radius and height for 2 different size cylinders. The formula for the volume of a cylinder is volume is equal to pi times radius squared times the height. Declare a constant called pi and initialize it to 3.14159. So we're going to have 2 cylinders, presumably a smaller cylinder and a larger cylinder. I'd like you to declare all variables as type double. The program will calculate the volume of each cylinder and then the difference between the 2 cylinders, the 2 volumes. The program will output the results in the following format. Note that the difference is expressed as a positive number. You can use the math.absolute value method that I just talked about back in slide whatever to determine the absolute value of the result. For example, if you have two volume variables, volume 1 and volume 2, well, you don't know which one is bigger, so you can use the absolute value method to just say, let's just subtract volume 2 from volume 1. If it happens to be negative, if volume 2 is bigger than volume 1, it'll be negative, but the absolute value method will go ahead and return the positive value. Be sure to use a program header block similar to the one below, and you can just copy and paste this and change the program author to be your name and whatever date you worked on it, and just the description I think is fine. Here are some sample runs that I did for when I wrote this program. We're going to get scanner input. It's going to ask the question, enter radius and height of the first cylinder. I put 1 and 2. The volume of the first cylinder is 6.28318. Enter the radius and height of the second cylinder. I put 2 for the second radius and 3 for the height of the second one. It calculates and says the volume of the second cylinder is 37.69, etc. The difference in the volumes is 31.4 whatever. I ran it again, and in this case, I gave it not integer input, but I wanted to make sure that double input worked. So the first radius I put as 1.6, and the height is 3. It calculates it, and the second cylinder has a radius of 4 and a height of 8.13. And it calculated its volume, and then I subtracted the two, and I used the absolute value method to determine that the difference between the two volumes is 384.5 units, whatever it may be. Please send your zip project file as an attachment in Blackboard message for class attendance credit. Another note is you do not need to create two scanner objects. You can repeat or you can reuse the object and just get new input from the console and still use the same input object. You don't need to do that twice. Okay, that takes us to the end of this webinar. Does anybody have any questions at this point? We have Eric, Joseph, Malik, Oscar, Sharon, and that's it. Everybody okay? Everybody good? Okay, if I'm not hearing anything, I'm assuming that there are no questions, so we will call this the end of the webinar, and hopefully the weather will cooperate on Wednesday, and we can meet. And any of you guys online, please send me messages or use the discussion tool if you have any questions. Thank you guys for participating, and we will talk again soon. Take care.